So the next type of electronic displacement in organic compounds is resonance. Resonance effect or mesomeric effect. So students find it very difficult to write the resonating structures, and more difficult part is they do not understand in which kind of system resonance is going to happen. So before moving into resonance, I will be discussing how to recognize a system in which resonance is going to happen. Okay, so let us start with it, and I will be sharing my screen again. Okay, so before moving into resonance, we need to understand what is a conjugated system or what is conjugation. Conjugated system. So once you understand what is a conjugated system, you will find it very easy to recognize in which system resonance is going to happen. And after that, we will learn how to draw the resonating structures. Okay, now, first of all, we will be discussing dianes. Now, if we break this word, it is di and ene. Di means two. Ene is used for a double bond. When a molecule has two carbon-carbon double bonds, ene is used for carbon-carbon double bonds. So when a molecule is having two carbon-carbon double bonds, it will be known as diene. So two carbon-carbon double bonds, if in the same molecule they are present, the molecule will be known as a diene. So dienes are of three types. Three types. Dienes are of three types. Number one is isolated diene. Isolated diene. Now suppose we have a carbon chain in which there are two double bonds, but the two double bonds, they are separated from each other by more than one single bond. More than one single bond. So this is a carbon-carbon double bond. Then there is a single bond. Then again there is a single bond. Then again there is a double bond. Now these two double bonds, they will be known as the isolated double bonds because they are having two single bonds. That is more than one single bond in between them. So if we have another chain in which we have three single bonds between the two carbon-carbon double bonds, it will also be known as an isolated diene. I think this much should be clear. It is very simple, right? Then the second is, so let me just clear my screen. Okay. So the second type of diene is cumulative. So sorry, it is Cu, cumulative diene. Cumulative diene. Now, in case of cumulative dienes, the two double bonds will be adjacent to each other. Carbon-carbon double bond, and adjacent to this carbon-carbon double bond, there is one more carbon-carbon double bond. So these kind of compounds which are having adjacent carbon-carbon double bonds, they're also known as allenes, and they're highly unstable. They are highly unstable. Now, third, the most important type of diene is conjugated diene. Third is conjugated diene. So in case of conjugated dienes, there will be alternate single and double bonds. That is, the double bonds, two double bonds, they will be separated from each other by one intervening single bond. So there is one double bond, then again there will be a single bond, then there will be a double bond again, right? So this is a conjugated diene. So these are the most stable dienes. most stable dienes. Now, understanding of a conjugated diene is very important to understand what is resonance. Okay, so let us now go into the detail of a conjugated diene or a conjugated system. So I'm just clearing my screen here. Okay, right. So we have already discussed what is hybridization. So now we are moving into conjugated system. Now, whenever a carbon is double bonded, it shows sp2 hybridization and it has one unhybridized p orbital that we have already discussed. So we are taking the simplest example of a diene, which is a conjugated diene. It is 1,3-butadiene. 1,3-butadiene. Now, buta is for 4 carbons, it is used. So 1, 2, 3, 4. Okay. At the first position and at the third position, we have a double bond. So first and third. So they are alternate double bonds. Right. Now, here we do not need to see the sigma bonds. We need to consider the pi bonds. Now, how a pi bond is formed? We have discussed that pi bond is formed by the sidewise overlapping of unhybridized p orbitals. Sidewise overlapping of unhybridized p orbitals. Now, because this is sp2 hybridized, this is sp2 hybridized, this is sp2 hybridized, and this is sp2 hybridized, this means all the 4 carbon atoms of 1,3-butadiene are sp2 hybridized. So if we complete the valences, it will be CH2, here it is CH, it is CH, it is CH2. Okay, now mainly we need the carbon chain here to discuss the conjugated systems. Now I'm drawing this chain again. Now all the carbon atoms, they have one unhybridized p orbital. So I'm drawing the unhybridized p orbital. Right? Now, if we need to show the double bond formation, we will be showing the overlap of these 2 orbitals and these 2 orbitals. Right? Now, these 2 orbitals, this one and this one, these 2 orbitals are also at the same distance as of these 2 and these 2 orbitals. Right? This means they can also overlap with each other. So we can show the overlapping of these 2 orbitals. Okay. Now all the orbitals are at the same distance from each other. They are on the adjacent carbon atoms. This means they can keep overlapping from one side, then from other side, then from one side, then from other side. And there will be, now in the orbitals, what is there? There is electron. In the unhybridized p orbital, there is electron. Now, these p orbitals, if they are shifting like this, sometimes here they are overlapping, sometimes here, right? If they are doing this way, this means the electrons are moving from one place to the other place, from one orbital to the other orbital. So I can show it like this. So this same structure, I'm drawing it again. You can just do one thing. Do not draw it here. Here you show just this bond, and then you can show it like this. Now what is happening? Above and below the plane of the carbon chain, there is an electron cloud. Now, just tell me one thing. If you keep on jumping from one place to the other place, one place to the other place, one place to the other place, what will happen? Your energy will fall. When the energy falls, you become stable. Then you sit calmly at one place. Same is the case with these electrons, because they are jumping from one place to the other place and they are consuming energy. For the movement, energy is required. So when the electrons will be moving from one atom to the other atom to the next atom, and they are continuously moving, this means they are consuming energy. When the energy is consumed, it will be decreased. Okay, now because the energy is decreased, the system becomes stable. So this is the reason for the stability of the conjugated systems, because energy is consumed for the delocalization of electrons. So now these electrons in these 4 orbitals, they are not having one position, that is, they are not localized, but they are localized, delocalized. They are not localized, but they are delocalized. So whenever there will be delocalization of electrons, there will be stability. So these are the delocalized electrons. So this system is stable because of delocalized electrons. I think this much should be clear to you. Now we will be moving towards resonance. But before that, I want to take more examples how you can recognize a conjugated system. So number 1 conjugated system is when there is a single bond between 2 double bonds. It is a conjugated system. Then the next conjugated system can be, okay, I'm just clearing my screen. Now suppose we have CH2 double bond CH, and then again CH2, and here is a negative charge. Okay, now this negative charge and this double bond, they are again at a 1 bond distance, 1 single bond distance. So these two will be in conjugation with each other, right? Now, if I say this is the case, now again, this carbon-carbon double bond and this positive charge on carbon, they are at 1 bond distance. Again, they will be in conjugation. So we have already done 3 types of conjugated system. 1, 2 double bonds separated by 1 single bond, then negative charge separated from the double bond by 1 single bond, then positive charge separated from the double bond by 1 single bond. Then suppose we have this free radical, okay? When the free radical is there at a distance of 1 single bond from the double bond, the system is conjugated. Clear? Okay. Then next, suppose we have this system, CH, or again CH2, and we have, just wait, I think I should take the other molecule. So this is vinyl chloride. Okay, now this chlorine is having 3 lone pairs. The distance between this lone pair and this double bond is 1 single bond. Again, it is a conjugated system. Now, in all these systems, resonance is going to happen. Simple. So how to recognize whether resonance is going to happen in a system or not? You need to look for the conjugation in that system. How to find out whether the system is conjugated or not? You need to look for 1 bond distance between a double bond and another double bond, a double bond and a positive charge, a double bond and a negative charge, a double bond, a free radical, a double bond, and a lone pair. Right? So next we will be discussing resonance or mesomeric effect. Write in the comments below, is it simple to find where resonance is going to happen? Write what you have learned in this very video, and I will see you in the next video.